In a previous video, I showed a Fischer esterification where we had an alcohol and a carboxylic acid and we made an ester. Well, if your alcohol is part of the same chain as your carboxylic acid, we can actually do an intramolecular Fischer esterification to get a cyclic ester known as a lactone. And so the first step, again, all the steps are the same. The first step is protonating our carboxylic acid to activate it. Now, depending on the professor, there's two acids that you could potentially use. One is just that sulfuric acid could directly protonate your carbonyl, or technically, that acid is catalytic. It will probably protonate your alcohol of another one of these molecules, and that could be the proton source. So either one of these two routes, in my opinion, is acceptable, but sometimes a professor likes you to protonate an alcohol, and that will then protonate your carbonyl. But regardless, the following steps are pretty straightforward, similar to the original Fischer esterification video I showed. So once we protonate that carbonyl, it's now activated. Now we can have our nucleophilic attack. What we're going to do is, through an intramolecular reaction, the alcohol part of this structure is going to cyclize and add to that carbonyl. And the result is going to be this cyclic structure. And sometimes it helps to number. If I were to number 1, 2, 3, 4, and make the oxygen 5, I know I'm making a 5-membered ring. 1 is going to be the carbonyl, which would be this carbon right here. 2 would be here, 3, 4, and 5 is the oxygen. I see a methyl group on 3, so there's a methyl group down there. Again, when you're doing these problems, I strongly recommend you number, not for nomenclature purpose, but for being able to distinguish where all of the substituents are, how big of a ring you're going to form, and so forth. So we cyclize here. The hydrogen is still attached to this alcohol piece here after it cyclizes. So we need to get rid of that. That's going to be a proton transfer to get to a neutral structure. And the base is going to be an alcohol from our starting material, just another one of those molecules that happen to be in the solution. Once that happens, we're going to move those electrons there. We are going to be back to a neutral structure. The neutral structure can then be protonated again with one of our acids, whichever one you prefer. So we now have a good leaving group, water. So what's going to happen next is the water is going to leave, but it's going to leave as we form our double bond. We're going to reform our carbonyl, kick out the water, and we have our protonated ester that we can then deprotonate in the last step. Again, our alcohol can deprotonate that, and we're back to our final structure. So the process is the exact same as the other Fischer esterification, except now we're forming a ring. We start with the proton transfer to protonate our carbonyl to make it more electrophilic. We then do our nucleophilic attack of the alcohol. The hydrogen on the alcohol needs to be removed to get to neutral, so we proton transfer. But then we do another proton transfer to get our leaving group, which is water. We then do loss of the leaving group by reforming our carbonyl, kicking out the water. And finally, we deprotonate, proton transfer, to get to our final structure. Just like with the other Fischer esterification, we can reverse the process by adding water in acidic conditions. That will push it back to the starting material. Again, I recommend when you do these problems, the trickier the problem is, the more important it is that you number your carbons so you know how big the ring is going to be and where all the substituents will be. Keep in mind that we're essentially doing a substitution, so there should be at least one proton or one nucleophilic attack and one loss of a leaving group. Everything else is just a bunch of proton transfers to activate an electrophile, prepare a leaving group, or neutralize the molecule. So if you have any questions, again, feel free to reach out. I am always open to making more videos to help you understand these various mechanisms and reactions.